Hi, my name is Jason Tsay. I graduated from ISR, the software engineering program, in 2017. Right now, I am a research staff member at IBM Research AI. I think like a lot of people my age, I think my path to computer science started with video games. Young age, loved them, love like Nintendo and everything like that. That kind of led me naturally to be like, oh, I wonder if I can make my own game. So I think I asked my mom to buy me some basic computer science like programming books. So I think I followed a book and learned to program in BASIC, for example. From there started to do more and more complicated things. And then yeah, I would say like that was definitely my start in doing computer science. Computer science is like you take this perfect like diamond theorem kind of thing and like computer science and it's perfect. And then software engineering is when you take that perfect diamond and you kind of drag it through the mud and actually try to build like a real life system. That always kind of stuck with me in that I think software engineering is exactly that, is trying to, when you take these very like formal or precise things and then you go into the real world and there's all these issues that kind of crop up, right? Like, oh, this didn't run the same way. This only ran on my computer. I added things and it fails. I added 3 more people and then everything is just, it just become chaos, for example. So in that way, I think like software engineering really is like that process of taking all the things that real life like throws at you, or maybe I shouldn't say real life, but that I guess like life throws at you, and finding ways to solve these problems in order to create some sort of software system. I would say that, for example, I think there's kind of a misconception that to be an effective engineer, it only really requires like programming ability or like some kind of like technical prowess. But really, I think there's a lot of other issues that come up to actually build a system, and these are all engineering issues. And I think software engineering is about dealing with these issues in a more repeatable and understandable way. In undergrad, I had spent a lot of time kind of developing these technical skills, right? Like, I don't know, operating systems, like software testing, even things like as electrical engineering programs. So I did a lot of like circuits and like that sort of thing. And when I took this software engineering class, it really opened my eyes to like this larger problem of how to actually build a system. I just kind of felt that really interesting. And also thought it was just really an interesting way to look at the world, in that it really wasn't like a technical issue. Like we weren't really using these projects, we weren't trying to develop these projects, but we kind of realized that there was a problem in that we wanted to understand how people did these releases. And then there's kind of that human aspect to it. Like when do you decide to do this? Like when should you do this? Like how can people make use of this information from these releases? We live in a very connected world, I would say. And I think software engineering is well poised to kind of do 2 things. One is to make building software systems more accessible to people. You see this with like kind of cloud computing and kind of easier, higher level like programming languages, for example. The floor is lower, or the barrier to entry is much lower now. But also because everything is kind of so connected, we see this in places like GitHub, for example. It's also much easier to coordinate with other people. So you can coordinate, you can collaborate, you can work together on things. Your programming ability will only get you so far, like sheer programming ability. But then one easy way to kind of scale up or to build even more complicated or larger systems is to collaborate with other people and to coordinate with them. And the kind of things that we have, like, like social media and GitHubs and things like that, I think enable that sort of collaboration. And I think software engineering as a practice really helps with understanding like how should we coordinate, what kind of things can we abstract away, what kind of things can we modularize. So it's like you work on this, I work on this, and that way we can actually build some larger system without stepping on each other's toes, for example, or destroying something, or doing that sort of thing. So the first part is how did I decide to do research? So one of my professors suggested that if you're unsure to do research or go into academia or just go into industry, as I was at that point, you should just try both and then see which one you like more. So I did both. I did internships, and then I also did this undergraduate research program with Dr. Perry and I guess now Dr. Wright. And I guess I mentioned earlier that I actually really enjoyed like my time doing that. So I guess that helped me decide to kind of look at consider PhD. And then the way I decided on CMU in particular was that Dr. Perry had suggested to me that my then advisor, Jim Herbsleb, would have been good. And so he suggested him to me, and then I applied, and then I went to go visit. And then I think at CMU, when I went to go visit the campus, I think I really enjoyed people were telling me that how, I guess, like collaborative, I would say, like CMU as an environment is kind of, it's small, but it's also very like inclusive. You kind of get exposed to a lot of different things, and I found something like really appealing about that. Also, just like all the people I talked with, I had great conversations. I just got really excited about going to CMU. So in the end, I went to CMU. Let's see. I think that AI development is such a like kind of a new and exciting field by itself. It's definitely very hot. Like it feels like every company and like all these academics are like really interested in it. But I also feel like it's exciting in that it's so new, but yet all of the kind of problems that we see with like software engineering and like all of the challenges are still applicable. And then I think there is a really big opportunity to kind of help quite a few people, I think, or to kind of change the way that people work, or kind of develop this like exciting like new field, I think. But I think really that CMU and ISR in particular was really good at was giving me opportunities to get exposed to a lot of different kind of like disciplines and ideas and people. Like, for example, I definitely talked to all the faculty within like ISR, and then most of the students, they would bounce ideas or get ideas. And then CMU, I think, has a really strong culture of working in different like disciplines, multidisciplinary, I would say. For example, one of my advisors actually was set in HCI. And so I got a lot of exposure to HCI and like HCI faculty over there, for example. And then even with working with them, they themselves have very diverse backgrounds. So I would learn about things like organizational behavior, like machine learning. What else I learned? Like HCI, of course. I learned a lot about like statistical modeling. Just lots of different kind of things. And you never really know what will actually be useful, I would think. So getting exposed to so many things was actually really important for me. Like even just one random meeting, I learned about like signaling theory, and that became the basis for my thesis. So I think like CMU is really good about that. And in the end, like I think going to IBM Research also has this kind of like open and like, getting exposed to a lot of ideas. So that's something that I found like really useful as like a researcher, or just something that really something I really like about research in general, I think.